Hey everyone, we are here with Alex, CEO of Matter Labs. He'll be doing a talk on zkSync, scaling DeFi with the magic of ZK Rollup. And I'll let him take it from here.
Perfect, thank you. Hi everyone. We're gonna talk about scaling today and rollups, ZK rollups, optimistic rollups, the trade-offs you can make so that this talk is gonna be about your options, how scalability can be solved on Ethereum today and in the near future. So let's see. Here we go. It happened again. We had the second scalability crisis after CryptoKitties, and it certainly will happen again if we progress on the big mission of crypto to bring cryptocurrencies and blockchain mainstream. And it really matters because if we don't bring it mainstream, we did not succeed. And this mission is what makes it valuable. That we have this peer-to-peer interactions, that it's completely barrierless, borderless, and so on. So if you followed Vitalik's Buterin talk last week on ETH Online, he spoke about rollups as the main path for Ethereum to scale, up to the point that Ethereum's roadmap will itself be adjusted to accommodate rollups. This includes ETH2, because they have this unique combination of security and decentralization properties, which help you preserve the values of Ethereum, and technologically also like the security, anti-censorship guarantees, and so on. The question is only how to pick a right rollup. So you know that we have two flavors. There are optimistic rollups, there are ZK rollups. People mix them up quite often. So I'm gonna spend quite some time talking about the differences so that we clarify what exactly makes one or the other one. So optimistic rollups are based on fraud proofs. That means the validators can progress the rollup to any state they want, but you're supposed to catch them if you see something fraudulent and incorrect. ZK rollups, on the other hand, are based not on economic incentives, but on math and cryptography. So what happens is, whenever you want to make a transaction on ZK rollup, this transaction is included in the block by the validators, and they must provide a proof of validity of this block, which includes proofs of validity of every transaction in the block, in order to make this state transition, in order for this block to be accepted by Ethereum and move on with your rollup. It brings a number of differences. So optimistic rollups are yet in testnet, but they are kind of coming very soon. ZK rollups are already live on mainnet with some limitations. But what's really interesting is that the one big thing which makes difference between the two approaches is that the fraud proofs limit the security guarantees of optimistic rollups to some amount of funds, which can be essentially, if you put more than a certain amount of value in a single instance of an optimistic rollup, you're inviting an attack vector on layer 1, which is described under this link. I'm going to post this link later in the chat. But the way it works is that someone can make a fraudulent transaction and then censor fraud proofs for an entire week, or threaten to censor the fraud proofs for an entire week using 51% attack, and then steal all the funds which you have in an optimistic rollup, which does not apply to ZK rollups. In ZK rollups, you can have unlimited total locked value, and they give you the passive security guarantees of Ethereum. So you can just go offline for a year, come back after this 1 year. No one has done nothing. It was completely unsupervised. and you can be sure that your funds are going to be there, and you will be able to retrieve them, no matter what the validators, sequencers, or other users do. So this is one big key difference. Another thing is differences in finality. Optimistic rollups require 1 or 2 weeks for being secure to delay the finality on layer 1 for any blocks of optimistic rollups. That means that if you want to move funds from layer 2 to layer 1, you will have to wait this period, like 1 or 2 weeks, or you need to use external liquidity sources, some payment channels, so someone has to put enough liquidity for your exit on layer 1 to happen in order to accelerate this. So you will probably need to pay a significant commission, some percentage of the value which you want to move out to these liquidity providers. In ZK rollups, the finality is reached the moment you create the zero-knowledge proof and submit it to Ethereum, which takes minutes. So right now it takes something like 20 minutes for zkSync. So that means you don't have to wait, you don't have to ask somebody to provide additional liquidity, you can just move out relatively quickly. Let's say it's comparable to exiting an exchange. Another interesting difference is that since ZK rollups are based on zero-knowledge proofs, they have this cryptography natively integrated, and you can have private transactions implemented on top of ZK rollup at a very small overhead cost. So they will cost you about twice as much as normal ZK rollup transactions, whereas on optimistic rollups, you will have to pay 20 to 100 times more, and 20 is still very optimistic. So we don't have proof systems ready yet, which will make usable proof systems such as Hello from Zcash, which will bring it to 20x. Probably you will still have to pay like 100x compared to a cost of a normal transaction. So as you can see, we have a number of trade-offs in favor of ZK rollups, but like what about the upsides? So up until recently, the optimistic rollups would say that you can port existing Solidity code to them without any modifications, and that was a really big deal. So you would have to choose whether you want to have that easiness of porting existing contracts, or you have to re-implement everything for ZK rollups. But luckily, we have some really good news. This is not the case anymore. The ZK rollups will be able to support essentially arbitrary contracts. So whatever you can do on Ethereum will be possible with ZK rollups, and you will be able to take existing code and port it to ZK rollup. And the way this is going to work is as follows. So recently we introduced the zkSync 2.0, the preview of the future version of zkSync, which will contain smart contracts. We did it in cooperation with Curve, so you can go to zkSync.curve.fi and try it out for yourself. It's live on our testnet, so all transactions actually happen on the testnet, and it actually works with the real Curve smart contracts, which we converted from Viper into Zinc. And what's interesting about Zinc, it's a language based on Rust, but it has all these smart contract features borrowed from Solidity. So it's isomorphic to Solidity in terms of syntax and all the constructs which you need for writing smart contracts. So what you can do is you can just take your existing Solidity code, and of course Viper code as well, and transpile it to Zinc. And inside that, you will have anything. So like literally anything doable on Ethereum can be done with Zinc. This includes composability. So you can call other contracts which are living in the same ZK rollup in zkSync, just the same way you would call them in Ethereum. So you can you just call this contract, you can deploy contracts, you can get return messages, and this all works atomically within the bounds of a single transaction. So you don't have to do anything asynchronous. If you want to interact with layer 1 or other layer 2s, you can do it with asynchronous messages, which which is going to be the case for any layer 2 solution. So you can't really avoid that. Now, the finality of these contracts is right now, as I said, around 20 minutes, half an hour. Of course, you have to wait for the block to be full, but the time to actually commit it to Ethereum is around this. However, we recently published a results from preliminary research on our hardware accelerators, and we're going to publish some more news later in a couple of weeks, which will bring down the time of finality to just a couple of minutes, maybe even under 1 minute. So we will see how that works exactly, but it's going to be much faster than proof generation with cloud instances, which we use right now. An interesting question is how layer 2 is going to be decentralized. So for zkSync, it's really important to us to have a layer 2 which is not controlled by a single entity, where we don't have just one operator, one sequencer which can manipulate stuff. So we will have a consensus mechanism in layer 2, which is going to be governed by a small number of validators who are nominated by a large number of what we call guardians. These are going to be people who hold zkSync tokens, and they only use these tokens to provide their delegated stake to the validators who produce blocks. And the guardians do not need to have high performance hardware. The validators will have to have it, guardians do not. So you will have a smaller number of validators, which will give you sub-second confirmations, because we can have really fast blocks. And the system is going to be 100% permissionless, because you will be able to, there is no single entity which controls this consensus. So someone will include your transaction in these blocks. You might ask or raise a question that if we have lower number of validators, it can lead to more centralization and to some increased risks of censorship in such a consensus system, which would be correct. So we want to introduce something which is enabled by the magic of zero-knowledge proof again, which is called time-locked transactions or time-locked encrypted transactions. This is going to work as follows. You as a user will submit a transaction which is encrypted, along with the proof that the payload which you encrypted for this transaction actually contains a valid smart contract call, and that you actually have money in the rollup to cover the costs for this call. The validators will include these transactions in the block, and they will not know what's inside. So the block is going to be formed, your transaction is going to be sequenced, you will get an instant confirmation within a second that this transaction is there. It's backed up by the stake of the validators. And then sometime later, maybe 10 seconds, maybe half a minute, the validators solve this time lock puzzle based on VDF, verifiable delayed functions. And then they can decrypt all the transactions in the block. And they learn the contents of these transactions. They can calculate the new root hash and make the state transition, but they cannot withdraw from the commitment anymore because they're going to be slashed. So this way you can prevent both censorship and also front running, which is especially important for DeFi because it's a huge drain of value on right now on Ethereum. So yeah, this is an overview of what you can do with zkSync 2.0, which is going to come next year, hopefully early next year. But you don't have to wait. You can actually use zkSync already today. It's live on mainnet. You can use it to scale payments. We natively support meta transactions. We have a bunch of projects who are already doing integrations. So you might have seen zkSync live in the recent Gitcoin grant round. Golem is working on this. Multis is working on this. We have actually a pretty large list of projects who are building integrations right now. You can use zkSync to make airdrops. An interesting thing about our implementation is that you can make payments or transfers of tokens to any Ethereum address. So the address which you're sending tokens to do not have to have an account in zkSync yet. They do not need to pre-register. So you can just send it to someone and they can claim the funds later directly in layer 2. So the recent airdrop by hacks created 200,000 accounts in zkSync. You can use multisig. We natively support multisig with a music scheme, which is an N of N multisig, but it can be easily extended to support N of M multisig. You can use it to do interesting things like atomic swaps, and you can implement some trading mechanisms already today. And also you can use zkSync because you have this low-cost transactions. You can build something interesting like payment links, where you send kind of a blank check to someone per messenger, and then they can claim funds in layer 2. And whoever gets the link gets to get the funds. So I encourage you to check out zkSync.io. We have a complete documentation for developers. You can go to wallet, try it out yourself. We maintain testnets on Rinkeby and Dropston. And yeah, thank you for listening, and I'm looking forward to the questions. So first question, what is the difference between airdrops and an ICO? Why are so many startups leaning towards airdrops versus ICO? So that is a rather contextual question for those startups. It depends on their business model. In an ICO, you get some funds from the users. In an airdrop, you just share tokens with some broad audience. So it's really up to the project to decide what they want to do. But if they decide for an airdrop, they can do it really inexpensively on zkSync today. Second question, can you explain the composability of, say, Uniswap running on optimistic rollup versus a ZK rollup? Example, would the LP liquidity user swaps also exist or perhaps sync simultaneously between the optimistic rollup, the ZK rollup, and layer 1? So, as I said before, composability between different layer 2s or between different layer 2s and layer 1 is always going to be asynchronous. We don't have any solutions which can support synchronous atomic composability, which we know from Ethereum, simply because layer 2 lives in a different time dimension. Time runs much faster in layer 2. You can have multiple transactions there while L1 remains unsettled and still waiting for the next block to be completed. So for this reason, how I see this working is rather you will just have a copy of Uniswap in every layer 2. Some of them will have more liquidity, some will have less. And the L2 users will be able to interact with this Uniswap inside layer 2 at low cost, high frequency, low latency. But if they want to go and trade, if they, let's say they don't have enough liquidity yet in a particular layer 2, they want to go to layer 1 and make interaction with Uniswap on layer 1. This is still possible. With ZK rollups, it's going to take them just a couple of minutes. So this latency window, it will be asynchronous. So they will send a message, wait for the block to be mined, and then get the message back with the swapped funds. With optimistic rollups, it's going to be more difficult because you will have to wait. So you will need some external liquidity provided from someone to be able to make these trades. An interesting aspect of scaling from layer 2, which you can do in this particular case, is batching transactions. So you can have many users who want to make a swap of, let's say, DAI versus USDC from layer 2, so they all have accounts in layer 2, in, for example, zkSync, they can make a transaction to a pool inside layer 2, get the funds together, and then the pool will have one atomic transaction to layer 1, make a big trade, get the funds back, and then distribute it inside layer 2 to all these different users. So this way you can kind of gradually introduce scaling into layer 2 while still have access to all contracts, any DeFi protocols on layer 1. Yeah. Any more questions?
Thanks, Alex. This was really great. If there are any last questions, please drop in the chat or in the Ask a Question section. Otherwise, we can take a short break. Do you have any closing thoughts, Alex, on like why zkSync is awesome?
Well, I just explained all the points. It's really up to the users to decide what's going to be the best option for them. So I'm really excited about ZK Rollups in general because because of all these differences, they really make the ideal scaling solution. It's not that we like really all advantages are on the side of ZK Rollups. Except maybe timing. So we need to see how fast things move, how fast people with optimistic rollups will be able to deliver solutions, how fast we will have full smart contract implementations in ZK rollups. Well, I think it's going to be really, really fast. From what I see, the progress people have been making in zero knowledge space in general this year, it's been mind blowing. So long term, there is no doubt that all blockchains will have to use something like ZK rollups. So it will definitely be based on validity proofs and zero knowledge proofs for scaling, because that's the only way you can actually preserve security and decentralization without any compromises and bring it to millions of users. And this is our goal as a scaling solution, because this is what protocols will need. But yeah, I'm just going to post the links which I mentioned before in the chat.
Cool. So you can drop in, ask a question, or you can tweet it and I can share it. But I think you have 2 more questions.
Sure. So the chat is disabled. So okay, let's see. So how do you envision ZK rollups being adopted by everyday people? At the moment, they seem not to have product market fit. So ordinary people do not need to adopt ZK rollups. They will adopt protocols. So they will have, for example, a smart contract wallet, which makes it very easy for them to get onboarded, to have some social recovery or alternative recovery mechanism where they don't have to bother with seed phrases. And they just get this wallet, they get an address, they send this address to somebody, get some tokens, they can trade these tokens, they can participate in DeFi protocols. They do not need to know that all of this is happening on layer 2. They just use, let's say, Argent or Dharma or any of these applications. So it's really all this magic is gonna happen under the hood, and users just interact with a nice UI UX provided by the protocols. And the ZK rollups are just gonna power those protocols to give them higher scalability and lower cost for transactions, and also protection from front running, protection from censorship, and so on. Next question. Can you please expand on the acceleration of verification and whether a consumer laptop would be able to run it? A consumer laptop will be able to generate proofs for individual transactions if we're talking about private transactions or this anti-censorship transactions, but you will probably not be able any near time to generate block proofs on ordinary laptops, because you need something like over 160 gigabytes of memory and lot of processing power. So right now we're using instances with 64, 98 core machines from AWS or Google Cloud, and this is going to be replaced by much more efficient hardware. So I don't see it becoming this, like, the marketplaces for proof generation might be a thing in the future with newer protocols which kind of support this proof generation from the ground up. But for the time being, I think that we will have this big providers who produce the proofs. The good thing is, you to become a validator, you do not need to own any hardware. You can always rent it from these big cloud providers just in time. So you only spin off instances once you have a block to prove and you already collected the fees for this block. So then you can spin off like 1, 2, 10 machines with or without FPGA acceleration, and then you run them for a couple of minutes, you produce your proofs, and then you shut them down immediately. So you're only paying to the cloud providers for this short time generating the proofs. What I can see happening is that the acceleration hardware will become decentralized. So people will be able to purchase these small gadgets which will produce the proofs, like Bitcoin miners, and they like everybody will have some small hardware running at home or attached to their computers, and then they can participate in this decentralized marketplace for proof generation, but like not with ordinary laptops. Next question. I heard a data scientist say that the real wars will happen between layer 2s and not layer 1s. Do you agree? I think that layer 1s compete on a different in a different dimensions. Layer 1s compete for being the most secure platform and the most decentralized one. So the core purpose of layer 1 protocol, in my opinion, is to be unstoppable. So you can have something really awesome like Libra or Telegram and have access to like billions of users, and not being able to launch your blockchain because you're a centralized entity and you get a letter from Congress and they just shut it down. So layer 1s are valuable because they have a lot of nodes and no one controls like majority of those nodes, and they run in different jurisdictions, and it's really hard to regulate and shut them down. So this is where layer 1s will have to compete. But they do not have to provide all the features out of box. They can, of course, rely on layer 2 for scalability, for privacy, for all the other things. Ethereum recognizes that, and this is why Vitalik announced that the ETH2 roadmap is undergoing some changes to be more rollup friendly and actually be all about rollup, rollups. So like rollups are now first-class citizens in Ethereum, and then layer 1 will only take care of execution of like the basic level execution, so committing the rollup blocks and providing data availability, and that's going to be its sole purpose, which makes a lot of sense to me.
Awesome. Thanks, Alex. So I think we're done with questions. We can transition to the next talk now. Really appreciate your time. This was great.
Cool.